Problem number 2. In how many arrangements of the letters in the word tenacious are the vowels in alphabetical order? Alright, well, let's take a look at this word. We have 9 letters, right? 1, 2, 3, 4, 5, 6, 7, 8, 9 letters. And how many vowels? Well, let's see, we have this E, we have this A, we have this I, O, and U. Okay, so we have 5 vowels, A, E, I, O, and U. So we have essentially all the vowels. And so we want to find all the arrangements of these letters. And actually I'm going to erase that because it makes it messy. We want to know all the arrangements of these letters in which the vowels are in alphabetical order. And let's look here. All of these letters are different, right? We don't have any other T's or E's or N's or A's or C's or I's or O's or U's or S's. Okay, so they're all unique letters. And so let's take a look at this. We've got 9 spots to arrange the letters, right? So let's just draw these little placeholders for the letters. 1, 2, 3, 4, 5, 6, 7, 8, one more. 9. Okay, so there's 9 slots. We want to take these letters and put them in these slots. Alright? So, we could think of it as, okay, let's fill the first slot, grab one of these letters, and then stick it here. Or we could say, let's take the T and choose a place to put it. Okay, either way. So it's good to be able to think about these problems in both ways. Of choosing a letter and putting it somewhere, or filling the slots one at a time. And it doesn't really matter what order you fill the slots, right? You could place, you could look at this slot and fill it first. Or you could take the A and put it down first. But probably the easiest way to do this is to because there's a restriction on the vowels. We want the vowels to be in alphabetical order. So there's a restriction on those vowels. But it doesn't really matter where the consonants go. So let's think about it in terms of placing all the consonants first. Okay? So how many consonants do we have? We have 1, 2, 3, 4 consonants. So we have 4 consonants and 5 vowels, right? So we've got 4 consonants. Let's say we're going to place the T, and we would have 9 places to put the T. Okay? And then let's place the next consonant and place the N. Doesn't matter. We could place the S next. Doesn't really matter what order we do it in. But let's say we're going to place the N. And so we've got one of them filled with a T. And so now we're only going to have 8 places left to put the N. Then we're going to place the C. 2 of the places are filled, so now we have 7 places left to put the C. And then finally the S, we can choose from any of the remaining 6 places to put the S. Okay? So there's no restriction on the placement of the consonants, all right? And the only restriction on the placement of the vowels is that they have to be in alphabetic order. But if we place the consonants first, then what we have left, we'll have 5 slots left for the vowels, and there's only one way to put the vowels in alphabetical order, right? They have to be A, E, I, O, and U. So if we place the consonants first, and we have 9 places to put the first consonant, 8 for the second consonant, 7 for the third, and 6 for the fourth. So by the fundamental counting principle, which just says that we can multiply the number of ways to get the total number of ways, right? So and then we only have one way to put the vowels in alphabetical order with the remaining 5 spots that are left after placing the consonants. Then we get 9 times 8 is 72 times 42, right? 6 times 7 is 42. If you multiply that out, we get 144, and we have 8, and then we have 28, right? So if we add that all up, we get 3024. So our answer is that there are 3,024 ways to place these letters such that the vowels are in alphabetical order. Okay? There's other ways to think about this too. I mean, you could think of it in terms of, you know, if there weren't any restrictions, we could place these letters. We'd have 9 places to put the first letter, 8, 7, 6, all right, all the way down to 1. So we have 9 factorial ways to place all of the letters. But some of those ways are not going to have the vowels in alphabetical order. So, and out of all the, given any replacement of consonants, there's only going to be one way to put the vowels in order. So then you could think of it as 9 factorial divided by 5 factorial, right? Because there would be 5 factorial ways to arrange the vowels, okay? But that just gives you the same thing, right? Because if we divide 9 factorial by 5 factorial, then the 5 times 4 times 3 times 2 times 1 would just cancel out of the 9 factorial, right? So we'd end up with the same thing. It's just like a little different way of thinking of it, but either way, the answer comes up to be 3,024.